So let's go ahead and create our permissions table. And this way we will be able to store our permissions that are allowed. And so we will be able to have a linking table that connects the users to the permissions. Okay, so that's our task for this video. So let me go ahead and create a migration file, a pair of migration files. So they will be called add permissions. Okay, let me copy this since I will need the name. Okay, let's start with up. Great. So what I want to do is to create a table, and so let me just copy this name. Okay, and so let's close that. All right. So probably should have typed it by hand, but I was a bit lazy. So we will call this table permissions. Okay. And this permissions table will have two columns. The first one will be an ID. Of course, we will call it big serial, of type big serial, and it will be the primary key. The second column we will call code, and it will contain the actual name of the permission, such as read or write. And of course, it will be not null. Now, let's create a linking table that links users to permissions. Okay, so this is an example of a many-to-many relationship. Okay. So we can have one user having many relationships. Having many permissions, or the user's name can be found in the permissions table many times, right? In the linking table many times. And a permission can be held by many different users, right? So one user, many permissions, one permission, many users. And so that's a many-to-many relationship. And as you know, there is no explicit way to specify a many-to-many relationship in Postgres. So what we do is to create a linking table, and we include the keys from both contributing or participating tables. In that case, we want ID from permissions and ID from users. So I will go ahead and create that table. Again, let me just copy and paste. So I will create a table, and this table will be called users underscore permissions. Okay, that's the name of our linking table. And this linking table will of course have the two foreign keys. So the first foreign key will be called user ID, and it will be of type big int, not big serial. Okay, big int, and it will be not null. And of course, we will see it references the table users and the column ID from that users table. On delete, we will cascade, right? So we will remove any child rows. So on delete, cascade. Okay, and let's do the same for the next foreign key that we create, and that will be a foreign key that will be a permission ID. Okay, so permission ID. And this column name, permission ID, references the permissions table, specifically the ID column. And so by doing this, we have effectively linked the three tables. The users table is linked to this users permissions table, and then this users permissions table is linked to the permissions table. That way we can read across all three tables. Now finally, I need a primary key for this linking table, and so since I want to create a composite key, I will just say that primary key will be made up of the user ID column and the permission ID column. So keep in mind that it's a composite primary key. So any of these columns by themselves does not make a unique primary key, a primary key. Only if we combine them do they uniquely identify a row. Again, this is something you probably know by now. Alright, so we have our linking table. The primary key is user ID, permission ID, and of course we will have user ID and permission ID. Great. So the next thing we want to do is to add a few entries to our permissions table. Alright, so let's just go ahead and say insert into permissions. Which column? The code column. And the values we want to insert will simply be single quotes, let's call it schools, colon, read permission, and a second one, schools, write permission. That's the end of our insert statement. Again, we could have put this on one line, so maybe I should put this on one line just to make it a bit more readable. Alright, so it will look something like that. However, in most cases you tend to see values on a separate line. Okay, so let's leave that like that, and let's perform the actual migration. But before I do that, I need to specify what should happen when we do the down. So let me close that. Let me open the down. So this one should be rather straightforward. All we need to do is to drop the tables. So we'll simply say drop table if exists and users underscore permissions and permissions. Okay, so we have our two drop table if exists statements, and so now I will go ahead and perform the migration. And so we'll say migrate, and the path, of course, where our migration files are found is migrations, and our database that we will apply the migrations to is Apple Tree DB DSN. Okay, that's the representation of our database, the name, environment variable. Okay, and we'll perform the up migration. Okay, so I'm missing something. Okay. Alright, so I guess I probably should just drop okay. So let me just do up. Okay, so see, I'm missing something. Let's see, what am I missing? Okay, I know what I'm missing. Anyway, I'm missing the database name. Okay, so let's run that. Okay, so it added back all my tables. All right, so if I come here, all right, I will see my permissions and user permissions added. Okay, of course, for me they'll be empty because I dropped all of them. Okay, so I did that intentionally, right? So let's, if I say done again, and I say yes, then all of them will be dropped, okay? And if I come back here and check how many tables, it's only the schema migration that's there, okay? Let me run up again, and that will bring them all back up, okay? So I could verify that quite easily, and I have all of them, okay? So of course, I don't expect you to perform a down to drop all your tables. So don't do that. I just wanted to do that to show you again the effects of migrations. So I have all my tables. Of course, they are now empty, right? So if I say select all from users, they're empty. Okay, but that's no problem. I have all my data. For example, I could add back my data from here. All right, let's just leave this here. We did quite a bit by creating these tables. And so now in the next video, we will go ahead and we will actually create our permission model, which, as you know by now, will allow us to actually access the database using Go. Alright, so that's the command pattern. You notice we create the tables and we create the actual models or the type, and because we now have a type, we are able to create methods where those methods contain SQL operations. So I'll see you in that next video.